Okay, so we're going to start talking about the exercise where we are trying to understand the relationship, if there is any, between the mean SAT reading score versus the mean SAT math score. So from the state of New York, Connecticut, Massachusetts, New Jersey, and New Hampshire, we have collected the mean SAT reading score as X variable and the mean SAT math score as the Y variable. Again, the premise of the problem is probably the conception that we have is someone good in reading is not necessarily good in math, or someone who is good in math is not necessarily good in the reading skills. So this problem is going to help us analyze that mathematically, whether there is a linear relationship between the reading math scores versus the SAT math scores versus the SAT reading scores. So let's see what are the questions asked. First question, of course, is asking you to find the slope and the y-intercept of the regression line. So we're going to go back to our Excel spreadsheet, calculate these two values. Remember, we are going to be needing to input all the data points, and these are your SAT reading scores as X. So I'm going to start putting those values in, and my reading scores are going to be 497, 515, 518, 501, 522. I will not be needing the last row. The mean SAT math scores are the Y values, which are 510, 515, 523, 514, and 521. So it has calculated the required information for us. The correlation coefficient is 0.8792. The slope is 0.4264 rounded to 4 decimal places. So we're going to answer accordingly. Slope is B1. So we'll say B1 is equal to 0. So let me check one more time. This is 0.4264. And then the y-intercept is given by B0, and that is equal to 298.8628. Next question is saying, state the regression equation in words that a non-specialist would understand. So first I want to write down the equation as a mathematical equation. So we'll say y hat equal to slope 0.4264 times x plus b naught, which is 298.8628. Now we will write it in words and help our interpretation. So what we say, remember what is y? Y is the mean SAT math score. So y hat is the predicted mean SAT math score, and then the equal, you can just write equals. So the mean SAT math score equals 0.4264 times, what is x? The mean SAT reading score plus 298.8628. So if I write the regression equation or the regression line this way, then anyone would be able to read this sentence and interpret that. So if you want to know the mean SAT math score for a state, all you need is the mean SAT reading score. What do? You multiply the mean SAT reading score by 0.4264 and add 298.8628 with it, and you get the predicted mean SAT math score. Interpret the value of the slope of the regression line in terms of the variables. Interpret the value of the y-
1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1.
Remember, the x increases by 1. So if the mean SAT reading score, that's your x, is increased by 1, then the mean SAT math score, and this time again I can say increases because my slope is positive, so the correlation coefficient is positive, so x increasing implies y increasing. So the mean SAT math score will increase by the slope amount. So I will say increase by, and the slope is 0.4264, and that would be the interpretation for the slope. Now we're going to interpret the y-intercept, and it is pretty similar. So we say when the x is 0, so when the mean SAT reading score is 0, the mean SAT math score is the y-intercept value, which is 298.8628. Interpretation for the y-intercept. Estimate the mean SAT math score for a stat with the mean SAT reading score of 501. So mean SAT reading score is your x. X is equal to 501, and you are estimating or predicting the mean SAT math score at 501. So what I do, the slope 0.4264 times 501 plus 298.8628 is the y-intercept. Use your calculator to find this value. So I'm going to go to my calculator and I will say 0.4264 times 501 plus 298.8628. And that's 512.4892. So that is the prediction or the estimation of the mean SAT math score. I'm done there. The next problem is asking me, is the interpretation of y-intercept useful? Explain. So remember, the interpretation of the y-intercept was when the mean SAT reading score is 0, the mean math score is 298.8628. It is not useful. So first we'll say that no, it is not useful. Why it is not useful? Well, as the mean SAT reading score cannot be 0. It is not possible to score 0 in the mean SAT reading. So what is the point of estimating the value of the mean SAT math score at that mean SAT reading score? That's why it is not useful. Is it okay or misleading to use the regression equation to predict the mean SAT math score for a state with mean SAT reading score of 400? So let's go back to our example. I want the mean SAT math score for the mean SAT reading score of 400. If you look at the range of the data for X, then 400 is beyond this range. 400 is smaller than the smallest data. So this is going to be an extrapolation, even if we want to find the mean SAT math score. So what we will say? We will say it is misleading. We should not predict a value for an extrapolation. It is going to be misleading to use the regression equation to predict the mean SAT math score for a state with the mean SAT reading score of 400, and the explained part will be as this would be an extrapolation. Let's see what else we can do with this exercise. What is the distinction between your result from part D and the mean SAT math score of the state New Jersey? So part D, we estimated the mean SAT math score for a state with the mean SAT reading score of 500, and the estimated value was 512.4892. So we write it first. So from D, y hat 501 is equal to 512.4892. Now let's go back to the original problem and see the mean SAT math score for New Jersey. The mean SAT math score for New Jersey is 514, and C, the mean SAT reading score is 501. So we'll say Y, the actual value for New Jersey, it's the same state because the reading score is 501, is 514. So the difference is what? So I'm asking you to find the prediction error. So Y 501 minus Y hat 501, actual minus predicted, is 514 minus 512.4892, which is equal to 1.5108. So that is the difference. And then it is saying calculate and interpret the prediction error for your prediction in part D. So we already calculated the prediction error. We will say the prediction error equal to 1.5108. Remember, this is positive, will help you interpret. So we'll say the actual mean SAT math score of New Jersey is higher than the mean SAT math score, or predicted, I should say, the predicted mean SAT math score of the state. So it is above the regression line. So the actual score is above the prediction line, the line of best fit, or the regression line. Would answer my question. We're going to come back to this example one more time in our next section when we're going to talk about coefficient of determination. But for the time being, let's focus on two other types of word problems. So let's read through this word problem one time. An analyst working for a telecommunication company has been asked to gauge the stress on its cellular networks due to the increasing use of smartphones. She decides to first look at the relationship between the number of minutes customers spend on talking on their phones and the amount of cellular data they use. She collects a month's worth of data on 300 customers. So this is the first numeric data, and I'm going to go ahead and say that N, the sample size, is 300, who have smartphones with data plans. The mean monthly call time was found to be 200 minutes. The mean amount of data consumed was found to be 422 megabytes. Based on the least square regression line, fitted to the data, it is found for every minute increase in the calling time, the data usage is expected to increase by 4.4 megabytes. So at this point, I have a little bit of idea. So if you read this last line one more time, based on the least square regression line fitted to the data, it is found for every minute increase in calling time. So calling time is X. So the mean calling time is X. As soon as I know that, I know in this situation, the expected increase 4.4 megabytes in the data usage is your Y. And remember, this type of statements are used in interpreting the slope of the regression line. For every 1 unit change in X, I have the slope unit change in Y. So what does it tell me? It tells me that B1 in this regression equation is equal to 4.4. Because for every 1 unit increase in X, the increase in Y is 4.4 units. Good. Predict the amount of data used by the customer who spends 368 minutes. So 368 minutes is your X, and you're going to predict the Y for that. Do not round in intermediate steps. So I'm going to work this problem out. So remember, for the regression line, I need one other thing. I need B0, and I do not know how much is B0 yet. But is there a way I can find it out? Well, let's first write down the regression equation. Y hat should be equal to B1 times X plus B0. What I know? I know B1, so I will say this is 4.4 times X plus B0. Then if you go back to the problem one more time, you have a little more information. You know the mean monthly calling time is 200 minutes. What is this? X equal to 200. And the mean amount of data consumed was 422 megabytes. So this is your Y, 422. These two numbers will satisfy the regression equation. So what I do, I go back to my regression equation, set Y equal to the value that I found for Y, 422, equal to 4.4 times the value you have been given in the problem, which is X equal to 200, plus B0. So 422 is equal to 880 plus B, 880. When you multiply 4.4 with 200, you get 880 plus B0. And see, this is going to help you find the value of B0. What do? You subtract 880 from both sides, and you get 8. 7 minus 2 is 5, 7 minus 4 is 3, but it should be negative, equal to B0. So now I have my regression equation. Y hat equal to 4.4x plus minus 358 is B0. That's my equation. If it makes sense, write it as Y hat equal to 4.4x. Remember, plus multiplied by minus is a minus 358. Looks better. Now I can go ahead and solve my problem. I want to know the predicted Y hat when X is equal to 368. So I'm going to go ahead and find Y hat at 368. That should be 4.4 times 368 minus 358. So let's work it out in my calculator. And all I need to do is multiply 4.4 by 368 and subtract, I believe this was 358, and I get 1261.12. So let me check my work one more time. I am going to multiply 4.4 with 368, and subtract 358, so I'll get 1261.2. 1261.2. That is your answer. So you're going to go ahead and say that the predicted amount of data used by the customer in megabytes when the customer spends 368 minutes is 1261.2 megabytes. Answers your question. There is a similar type of problem, and that's the last problem for this section. We'll work it out. Again, we're going to first read the problem, understand the x variable, understand the y variable, understand the slope of the regression line, the y-intercept of the regression line, and do the appropriate prediction. The director of an alumni association for a university wants to look at the relationship between the number of years since graduation and the amount of monetary contribution an alumnus makes to the university. He collects data on 50 alumni, so that's the sample size. Even if we do not use it, we should write it down, who have made contributions this year. The number of years since graduation has a mean of 4, and the amount of contribution has a mean of $161. Based on the regression least square line fitted to the data, it is found that for every year increase, so this is 1 unit increase in what? In the number of years since graduation. So since graduation, number of years is your x. The contribution is expected to drop by $36. That's interesting. So clearly the contribution is your y, but it is dropping. So the slope is negative because increase in x is resulting in decrease in y, so the slope is negative. So the first information I say, B1 is equal to negative 36. Now when we understand what is x, what is y, we will go back and we'll find out the number of years since graduation has a mean of 4. So this is your given x value. Has a mean of $161 is the contribution. So this 161 is the value of y, and then do the same thing. So first we need to get the regression line. Y hat should be equal to the slope times x plus the y-intercept, which we do not know yet. But we know a given x value and given y value, 4 and 161. Put them in. 161 for y minus 36 times 4 is for x plus b naught. So I get 161 equal to 36 times 4 is 144. Clearly it is a negative value plus b naught, and 144 on both sides. So I get 5. 6 plus 4 is 10. 1 plus 1 is 2 plus 1 is 3 equal to b naught. So the complete regression equation is y hat equal to minus 36x plus 305. What is the question in this problem? Predict the amount of contribution made by an alumnus who graduated 3 years ago. So your x is 3, you want to predict the amount. So let's go ahead and find it. Y hat at 3 will be negative 36 times 3 plus 305, and that will be equal to minus 108 plus 305, and the rest is subtraction. 15 minus 8 is 7, 9 minus 0 is 9, 2 minus 1 is 1. So this is 197. Answers my question. So I will go ahead and say that the predicted contribution of an alumnus who graduated 3 years ago is $197, rounded to 1 decimal place. I mean, we didn't round anything, but that's the final answer to the question. In our next video, we will talk about more about regressions and especially coefficient of determination and its interpretation.